Hi everyone. Today we are going to discuss work and time related problems. Before we start, I thought I'll discuss a few assumptions with you which we usually take while tackling these kind of problems. So, suppose if you have a wall to be constructed. Suppose this is the wall which is supposed to be constructed, right? So first assumption which we usually take is we consider the whole work as one unit. Suppose this is the wall which is to be constructed. So we'll take the job of construction of this wall as one unit, right? So first assumption is consider the job as one unit. And what is the second assumption? The second assumption is we assume that a particular person works at same speed throughout the job. That means if he finishes 1/10 of the job in one day, in second day also he'll finish 1/10 of the job, right? And on third day also he'll finish 1/10 of the job. So the working capacity of a person remains constant throughout the job. That is our second assumption. We do our calculations based on this assumption also. So this is our second assumption. Working capacity, we usually refer to the work done by a person in one day, and the working capacity remains constant throughout the job, right? And we do one more assumption, that is the third assumption. And this assumption we usually do when we calculate how many people will be required to finish the job. The assumption we do is unless it is specified, every person, every worker work at the same speed. That means the working capacity of all the people is same unless it is specified, right? So the third assumption is unless specified, working capacity of all the workers is same, right? So these are the few assumptions. What are those assumptions? The assumptions are we consider the job as one unit. Second assumption is the working capacity of a person remains constant throughout the job. And third assumption is unless it is specified, we assume that the working capacity of all the people working for the job is same, right? So these are the three assumptions which we usually do while doing the calculations in work and time related problems. And now let's discuss how we proceed with the calculation part of time and work related problems. First assumption is we always consider the job as one unit, right? So if this is the job, we consider as one unit, okay? And then we talk about the working capacities of a person. So the working capacity, we always talk in terms of how much fraction of the job a person can complete in one day. Suppose there is a person A and he takes 10 days to finish the job. The working capacity of A, I'm writing it in short, working cap, WK cap of A will be 1/10, right? Why? Because this much job, this much fraction of the job he is finishing in one day. So the working capacity of a person is 1 by the number of days he takes to finish the job, right? And this also includes the assumption that he works at a constant speed. If a person is taking 10 days to finish the job, in one day he will finish 1/10 of the job. This includes the assumption that he works at a constant speed. So this is called the working capacity of a person, this much part of the job per day. So this is the working capacity of a person. What does this actually means? He is finishing job as one unit. We consider the job as one unit, and he is finishing this much part, which is 1/10 of the job, right? So A is finishing this much part in one day. And there is one more person, B. He finishes 1/5 of the job in one day. How many days will he take to finish the job? Yes, 1/5 of the job is finished in 1 day. So to complete the whole job, that means 1, he will take 1 divided by 1 by 5. That is 1 multiplied by inverse of 1 by 5, which is 5 by 1, 5 days. Right? Now you understand why we inverse the working capacity while calculating the number of days a person will take to finish the job alone. This is the logic behind that. So if a working capacity of a person is 1/5, if a person finishes 1/5 of the job 1 day, if he is allowed to work alone on that job, he'll take 5 days. So this is one part of the calculation. And how we handle when two people of different working capacities work on the job? Yes, we first find out the job done by them in 1 day, and then we proceed with our calculations as I had discussed. Suppose A takes 10 days to finish the job, and there is one person B who takes 20 days to finish the job. Then working capacity of B will be, the work done by B in 1 day will be 1 by 20, right? And if both of them are working together, what we do, how we proceed with the calculation? We find out in 1 day how much fraction of the job they will finish. So in 1 day, A will do 1/10 and B will do 1/20, right? And then what we do is we find the LCM of this. LCM of 10 and 20 will be 20. 10 2s are 20, 2 1s are 2, and plus 20 1s are 1. 1 multiplied by 1 is 1. So the job done by A and B together in 1 day will be 3/20 of the fraction. So they will take 20 by 3 days to finish the job. So together, if they work, they are going to take 20 by 3 days. You can simplify this fraction, convert it into mixed fraction, and then you can write the answer. But what about their salaries? Since their working capacities are different, their salaries should also be different, right? A person who is working more or who is finishing bigger fraction of the job should be paid more, right? Isn't it logical? Yes. So now let's discuss about their salaries. Their salaries will be in proportion to the work done by them in 1 day, right? That's very logical. So the ratio of their salaries will be in proportion to the work done by them in 1 day. So the work done by A is 1 by 10 of the job, and work done by B is 1 by 20th part of the job, right? So their salaries will be 1 by 10 multiplied by inverse of 1 by 20, that is 20 by 1, right? So their salaries will be in the ratio of 2:1. So the ratio of the salary of A to B will be in proportion to 2:1. So if B gets 1 rupee, A should get 2 rupees per day. Why? Because A is working double as of B, right? So this is the way we find out their salaries. Okay, and now we will be handling few problems, and if you have any doubt, watch these videos again and you will clear all your doubts, right?